Hello everyone. In this session, I'm going to start chapter 2 because in the last session we did this chapter 1. So in chapter 2, first we'll talk about the different options in HVAC industry like consultant, contractor, etc. Then we'll talk about the different types of drawing, and we'll discuss how this process in actual practice for the designing point of view as well as for installation point of view. And we'll also discuss about the other services in this process, and who is architect and who is consultant, who is a contracting company, etc. All this we'll discuss. So especially if you are a beginner, this session is very important for you to understand the process for this building industry. Okay, and the steps involved in HVAC designing and the steps involved in HVAC installation. Okay, so if you are experienced, then you know all this process because you're already working. Maybe you are working in a consultant side, or maybe you're working in a contracting side. So you may know this process. But if you are a beginner, this is very important for you so that you'll get the mindset. Means you can understand what will be your role as a design engineer and what will be your role as a site engineer if you're working in a consultant side or in a contracting side for design, for execution, etc. So let me proceed. I'm going to share the screen. So here on screen, you can read chapter 2. So chapter 2 is about the HVAC industry overview, or I can say the building services, how this process in actual practice. Okay. So now in market, you'll find the BIM process, building information modeling. So that BIM process we'll discuss in some other day. At this level, let me start with the very basic. We'll try to understand the terms and terminology, the different types of company, the different types of layouts, nothing but the drawings, etc. If you're already working in this industry, you know about the consultant. Okay. But for beginners, you see, generally consultant refers to this design side. Okay. So again, in consultant also, you'll find this client consultant or design consultant. So at this level, I'm not going in detail. Just I'm trying to give the basic idea. So the detail about the process also we'll discuss. But at this level, first of all, let me give you the brief idea about the process. Okay. So in consultant, you'll find two options. One is a owner consultant and the second is a design consultant, or I can say the main consultant or the design consultant. Okay, so we'll discuss more about this. So what are the departments in the consultant? So here I've given the list just to get the quick idea at this level. Okay, so at this level, if you're not getting the idea, so don't worry. Let me proceed. When we talk about the steps involved in designing or this installation side, you'll get more idea. So what are the departments or what are the sections in the consultant side? So you'll find the sales department, so from which they can means the company can get the project. Then you'll find the designing department. Then you'll find the drafting if it is a big company, or else you can go for a designing and drafting in one division. Next, supervision and the Q and QC. And QA QC, this is for the design side, not for the not for the installation point of view, because consultant means they are not on site. They're dealing with the design point of view. I'm talking about the design consultant. Okay. Next, if you talk about the contractors or the contracting company, you'll find the sales division, then the purchases, then design review division, then this drafting for preparing the shop drawing, because the contractor will prepare the shop drawing. You see, in actual practice, you'll find the different options. You may find the design and build project. If the design and build project means one main consultant will take the responsibility. At this level, assume that I'm considering a separate consultant company and separate contracting company. It can be a one company who's taking care of all this. Because you see, in actual practice, if you're working in say Qatar or in any country, and if you're dealing with the big project, you may find one company dealing with all, or else can be a different companies. So in actual practice, you'll find the multiple option. So don't get confused. At this level, just try to focus on the concept. So here in contracting also, you'll find the sales, purchase, the design, drafting, execution, supervision, and QAQC. And you see this execution in the contracting side, and here in designing in the consultant side. Okay, because generally consultant refers to the design side. I'm talking about a design consultant, and the contracting refers to the installation execution side. Okay, again, in that contracting company, you'll find the subcontractors. So it's a big process for big project. For small project, the things are not that much complicated. So we'll try to understand the process of this services or this designing and the execution in actual practice in this session. Similarly, you'll find the separate maintenance company or the contracting company may take the maintenance, or generally in actual practice, the contractor who complete the job or who complete this installation will take care for this maintenance also. Okay, like 3 years maintenance or 5 years maintenance, they need to provide that maintenance as a part of their the project scope. Or it can be a separate maintenance company that includes again sales division, purchase division, service, cleaning, etc. Okay, so this is just to get the idea. No need to write. I'll share you these notes. Just focus on screen. If any additional points, I'll inform you to write. Just focus and try to understand the process. So now we'll discuss how this HVC project executes in actual practice. Because in this training program, we bother about this HVC service. No? So my focus is on the HVC system. Apart from this, I'll give you the idea about the other services also for coordination is required. But at present, as per this course syllabus, my intention or my focus is on the HVC system. So first we'll discuss the design steps or the design procedure for the HVC side in actual practice. Okay. So if you talk about the designing the HVC system, and you see this process is similar even for other services. At this level, here I'm focusing on for HVAC, but even for other services also, you can consider the similar process with few changes. So you see the first is a client in the list. So client means whom? You see, you can call client, you can call customer, you can call owner, etc.
Client who means who give a project for execution.
Yes. So who required to initialize the project? Na? So assume that you are the client and you are interested to construct a villa or a high-rise building, whatever, or a hotel or a school, etc. So assume that you are the client. Okay. So as a client, in actual practice, to whom you are going to contact to get this information or to start the project?
Architect.
Yes. And who is the architect?
Architect means
Who
design the building design.
No, I don't think. Who's doing space planning?
You see, here we can say architect or we can say the main consultant. Okay. Yeah. Or I can say this owner consultant. Generally, for a small project, we can say architect because architect will take care for overall building planning and design. But it not mean that he will design the HV system, he will design the plumbing, firefighting system, etc. No, but he will take care for overall planning of the building, the idea. So if you talk about this main consultant or say owner consultant, in that you may find the different engineers, including the architect or a senior mechanical engineer or a senior electrical engineer. So initially, under architect, you'll find all this because architect is not just a civil engineer. He is taking care for including the services also, means the overall planning of the building. And if you talk about this in engineering also, if you talk about this B-Arc compared with the B-Tech civil or mechanical, B-Arc is not 4 years, it's 4+ years, nearly 5 years. And they are going to learn this civil side and also this building services. Means they know the overall picture of the building, including the services. So they can able to coordinate with the services and initially they can initialize the project. Okay, so generally we can, as a client, we can contact to the architect or I can say the main consultant in actual practice for big project. For a small project, you can contact to the architect and he will initialize the project and he will prepare the architectural layout, including this structure at the initial stage, like concept drawing. And with that, he can float that to the sub consultant who is taking care for different services. So in actual practice, you may find a separate sub consultant for different services, or you may find one consultant taking care for all the services. So in actual practice, you'll find multiple options. So you may find the separate sub consultant or you'll find one main consultant. Again, in consultant, we have a design consultant, we have a main consultant. So a design consultant basically is for designing point of view, but main consultant will take the complete responsibility for big projects. So at this level, I'm considering architect, but if it is a big project, you can consider the main consultant or the owner consultant. Okay. Getting a point online?
Yes, sir.
Just try to visualize the process, try to visualize the concept, because in actual practice, as per the type of project, this process may vary. For very small project, we don't take for all this thing. One engineer will take care for all this. Okay, or for small project like in India, We don't require a separate designing for plumbing. The plumber will take care of this. So the options will change accordingly as per the type of project or the size of the project or location, etc. So here what we are discussing is a standard process. So you see, as a client, you're going to contact to the architect or to the main consultant, and who will take care for overall planning of the building. Okay. And after that, you see, this architect, he will provide that architectural layout. So he will prepare the architectural layouts, initially a rough sketches, not in detail. And he will provide this information to the different services or to the different sub-consultant, or one consultant may have all this. So you see, these are the different services, the firefighting system, electrical system, HV system, structure. Again, you see structure based on the load of the services, and you find some other consultant for this security side, or for elevators, for accelerators, etc. So this is for the design point of view. So we have some important points to discuss. You see, design of the large building project is an extremely complex task. It's not easy. Why? The main reason is what? Because you'll find n number of services, and if it is big project means it's not easy because of coordination issues. So you see, design of a large project. So you see, design of a large building project is an extremely complex task. It may take months or even years, and to complete, and may involve n number of engineers. But if you talk about a design of a small project, one engineer or two engineer can take care of this. Next, further, you see the design for the HV system, because here at this level we bother about the HVAC, so directly in the notes you'll find related to HVAC. But again, if you are dealing with other services, the case is similar. But here, the design of HV system for large project is a responsibility of whom? The consultant company who is taking care for this HVAC, or it can be a consultant taking care for all the services, or specifically for the HVAC. At this level, we are talking about HVAC, so that's the reason I have written this HVAC consultant company. Okay, so remember, the design will take care by the consultant, and the installation is going to take care by the contractor. Or if you talk about the main contractor may take the responsibility of both. That is called design and build project. Okay, at this level, I'm just considering this as a separate. If it is a main contracting company, the case is different for big projects. So in actual practice, you may find that options also. Okay, so don't get confused. At this level, just try to understand as a separate consultant separate, and contracting separate. So here, the design for the HVAC system for large building project is a responsibility of a HVAC consultant company. Consultant engineers may also carry out such other duties such as cost estimation and field supervision. On site, they will supervise also, but it not mean that they will involved in the installation. The installation part will take care by the contractor, or again you may find the subcontractor. Okay. Next, you see, each of these tasks is performed in cooperation with whom? Architect, as we discussed, or we can call the main consultant, or in design and build project, you can consider the main contractor who carry out the overall building planning and design. And the next point is very, very important: coordination between the architect and the services, and in between the services, is very important and difficult task. And if any error in the coordination will give you the disaster result. For example, if you talk about design site, in design, before completing this electrical design, if the HVC people complete the design, so then what will happen? I'm talking about this placement of 8 terminals, duct routing, etc. before this electrical. So what issue will arise? Yes, online.
I mean, electrical services are above the ducting and all this.
You see, one example, even the beginner also can relate this. So everyone knows the light fixtures, right? Light fixture you'll find in the false ceiling. No? Just I'm saying, taking simple example so that even the beginners can relate. So everyone know this light fixture, right? So for example, here is a plan. In that, these are the locations for the light fixture. And if this information is not aware by this HVAC design engineer, what will happen? They may utilize this space for placing the A terminals like diffusers. So what will happen? In drawing, it's possible, but in actual practice, in one location and at the ceiling, at the false ceiling, you cannot place the two different components, right? This is one example, simple example, so that you can relate. So the coordination is required even in design also. Definitely is required at the time of installation. That is very important. But even at the time of designing, the coordination is must. And for that we have a BIM process, and for that we have advanced softwares like Revit. Anyhow, this course is not for Revit. Revit we are offering as a separate course. And if you think that I'm promoting Revit, you're not completely wrong. So I'm promoting the Revit because now in market, maximum the big consultant or many countries, they're using this Revit software because Revit work on the BIM concept, especially for this coordination point of view. It's a very advanced process. Okay, so in some class we'll talk about that BIM concept. Next, so coordination is very important at the time of design stage as well as at the time of installation. At this level we are talking about the design side. Next, you see the steps involved in HVAC, because here we in this training program we bother about HVAC, so we'll discuss the steps involved in the HVAC designing, so that at the time of designing also these steps will help you. And this can be asked at the time of interview also, very basic question. So if you are applying for a design engineer, you can expect this question, the steps involved in the HVAC designing, and that too in order. So here the first step is a building survey. But you see, all these services can design after what? After getting the architectural layout only, no? Initially,
Yes,
if you talk about the concept drawing or concept stage or very initial stage, that case is different. But again, for example, if the design consultant want to design any service, the reference is what? The architectural layout. Because all the services for what? For designing and installing for the building, no? So the architectural layout, the building layouts are required. So just assume that the architectural layouts are ready. So when we get as a design engineer working in a consultant for the HVAC side, the first step is what? You see, building survey. And we have a separate chapter for building survey, which is chapter number 6. After completing this basics up to chapter 5, you'll find all the basic, and which is also very important. But the designing part start from chapter 6, and that is building survey. So in building survey, we are going to extract the information from the architectural layout, from the electrical service, and from the different people, and we'll prepare a file called input file. And based on that we can start the load calculation, and based on that only we can able to select the type of system. So at this level you may not get this terminology if you're a beginner, but don't worry, we have a separate chapter for all the steps. At this level just I'm giving the idea so that you can get the mindset. These are the steps for the designing, and later when I expand this steps, you'll get the clear idea. So at this level, building survey, it not mean that land survey or level survey. That land survey, level survey will take care by the civil people. But as a mechanical or electrical engineer, building survey refers to extracting the information from the architectural layout and understanding the requirement for the building, getting the inputs from the client, from the other services, to prepare a list of information that is called input file. Based on that, we can start the designing for the service. And this is very important, because you see, nothing is fixed in actual practice. Suppose if you're working in a consultant as a design engineer, suppose one time you may get the project related to say application as school. Next time you may get say office project. Or else you may involve in any industrial project. So what do you think? The requirement for this different application is going to be same or different? Different. So that says in extracting the information is required, then only you can able to design as per the application or the project or client or location or authority requirement. Right. So that's the reason this building service is important. We have total 17 points to discuss in detail in chapter 6. Next, based on that, we can think for selecting the system. You see, don't get confused here. Equipment selection and system selection both are not same. System selection means selecting the type of system which suits the building requirement or the client requirement. That client requirement means I'm talking about the budget point of view, or the architectural requirement, interior requirement, etc. And selecting system is not just a technical part. You need to consider this other people requirement also. And here system selection refers to, for example, suppose assume that you got a very small villa project. So in the small villa project, we are not going to suggest chill water system. At this level, you may not know what is chill water system. So at this level, you see chill water system is generally for big project. For small project, you are going to suggest what? Window or split? Okay, window. Okay, you forget about the window. Window is not a standard. So you may suggest the split system, or you may suggest the
VRV system.
VRV system or package or ductable. You will not suggest for the chill water system. Chill water system also available with the 15 TR capacity. In special cases, one can use, but generally for small villa project, nobody will install this chill water system. We have other and easy. We have other option which is budget friendly and space friendly. Okay, so system selection means based on the building survey as per the architectural requirement or the application requirement or the client budget, interior requirement, etc. Will select this system is best suitable for the particular type of project. So we are going to suggest, but again, final decision depend on the architect as well as the client also as per the requirement. So based on the building survey, we'll deal with the selection of system. And you see, for selection of system, you must know the knowledge of the different systems, no? And for that, we have chapter number 5. In chapter number 5, we'll discuss the different types of system, right from window to chill water system, including the air cooled, water cooled, VRF package, ductable, etc. So basically, the system is divided into 3 categories. One is a DX system, second is a chill water system, and third is a all air system. Again, all air system can be a part of a DX system, can be a part of a chill water system, or else widely, if you classify means, you'll find 2 systems. One is a DX and second is a chill water system. Apart from this, you'll find this radiant type or radiant cooling, some advanced option also, but what is commonly used in market, DX and a chill water system. Next, we have the lengthy part and important load calculation. And you see, in load calculation, we'll find the cooling load calculation as well as the heating load calculation, cooling load calculation for summer, heating load calculations for winter. And as per the syllabus, first we'll deal with the manual cooling load calculation, then E20 chart, then E20 Excel, then we'll start the software calculation. And as per the syllabus, I'm offering HAP, Carrier HAP. You may find the list of softwares for the load calculation. The list I'll provide, but as per the syllabus, I'm offering Carrier HAP. And this is a important and lengthy part of the syllabus. And this I'm just considering this in a 2-part. You see, basic is part 1 and manual load calculation is part 2 and software load calculation is part 3. So only this load calculation consists of 2 parts in the syllabus in module 1. And it's lengthy, very, very important. And based on this load calculation only, we can think to deal with the equipment selection. So what is the difference between system selection and equipment selection? Any idea? Any guess?
Yes, sir. System selection means which system is provided by smaller equipment,
Yes.
like
For example, right.
like as split AC,
Yes.
HU हो गया, FC हो गया,
Fine.
etc.
Then what about equipment selection?
Equipment selection, like AHU, air handling unit.
So here, you see, don't get confused. Equipment selection means of the selected system.
Yes, sir.
Based on the results, based on the results, what we are going to get in the load calculation. For example, initially I decide to go with the split system for a small villa project. Okay, so what I did, I just decide this system I'm going to use. But what capacity of that system? You'll get capacity in the load calculation.
Yes, sir.
After load calculation, we'll do the equipment selection of the selected system.
Yes, sir.
Okay, so selection system is just we are deciding how we are going to use that system, but actual selection is going to be after getting the required capacity based on the load calculation that we used to call equipment selection. Okay, under equipment selection, you'll find this AHU selection or a package, if it is a package, or chill water system, whatever. So based on the capacity, using the catalog from the vendor in a consultant side. Again, in the contracting side, the actual selection and the actual model number will take care. Again, submittal, the process that we'll discuss later. Next, you see, if you talk about aid side, we have aid distribution design. If it is a central air conditioning system, you'll find this ducting also. So you'll not find the ducting for the split or for a small unit. But if it is a ductable or if it is a chill water system, you'll find you need to design separate air distribution side also. That includes duct designing, this terminal selection, fan selection. I have given only the major points. Again, in that you'll find the list of options to discuss. So in short, that part I'm considering as a air distribution design. That includes the different methods for duct designing, different material for the duct, different types of air terminal, and we have a separate calculation for the ducting with the manual chart and table, or using duct sizer, most commonly McVie duct sizer in actual practice, or else you can use any duct sizer. The result is going to be almost same. Or this terminal selection, again terminal selection with the manual catalog or with the electronic catalog from the vendor. Then fan selection, very very important. In that we will find the term called ESP calculation, very important for interview point of view. All this will design in the air side. Next, if it is a chill water system, for example, at the time of after building survey, if you decide for the chill water system is, it can be air cooled system or it can be water cooled system. For that, you'll be required this chill water pipe designing. Okay. So see, if you talk about this designing is divided into three major classification. One is a load calculation, second is a air system design, and third is a water system design. And water system design is for chillers only, not for DX system. Okay, and if you talk about the VRF, then separate VRF pipe sizing. That also we'll discuss. You can consider this ductable split as a DX system, or split system as a DX system. Even VRF also a DX system, direct expansion. Okay, and the chill water, air cool and water cool comes under chill water system. But don't worry, if anyone don't know the difference of the system, we'll discuss in detail in chapter 5. Because see, in one class you cannot learn all these things, so you may not if someone is beginner, you may not get the terms and terminology, or else even experienced people may get confusion, because you see in some location the terms and terminology is different. Okay, in actual practice, based on the location also, these terms and terminology will change. Okay, so don't get confused, we'll discuss in chapter 5. Now, so this chill water pipe designing also very important, and for interview point of view also very very important. And generally for big projects you'll find chill water system. In that you'll find the pipe designing with the velocity method, with the Asher method, etc., which I've given at the starting session in the syllabus. So I'll not repeat that one, because we have a separate part for this chill water sizing part. Actually, it's a part 5. You see, part 4 is air side in designing a model 1, and part 5 is a chill water side. Fitting and accessories, we used to call valve package or hookups. Then pump selection, very very important for design point of view. Then apart from this, you'll find this control system design. I'm talking about the BMS, which is not included in the syllabus. I'll give you just the overview of BMS, but not in the syllabus, which is also required. Generally, this will take care by this electrical people or this instrumentation engineers, etc. This BMS part means control system. Next, planning the location of each piece of equipment in the building. Okay, so these are the steps for the HVC designing, and each and every step will expand in detail in the future in the next classes. Okay, so at this level, just to get the idea for the sequence of designing. Okay, so the major part is what? Load calculation, air side and the water side. Okay, and load calculation is common for any equipment. If it is a DX system or if it can be a chill water system, we require the load calculation. But this chill water, this ducting and chill water is for central air conditioning system, and chill water specifically for air cooled and water cooled chillers. Next, so next we'll talk about the installing the HVAC system. But before this, we'll talk about the types of drawing. Again, this is also very basic to understand the terms and terminology. And these types of drawing, this general drawings is common for all the services, including the architectural and structural side. Okay. But before this, do you know the difference between architectural and structural side online? Anyone? This architectural and structural.
Architecture means a space plan. Structures means beam, column, slab.
Yes. So if someone don't know, please make a note. I request to maintain a separate running notes also. So I'll give you some few points which is not in the notes. So you can write. You see, as a mechanical or electrical engineer dealing with the services, you should have some basic of this civil side also. So you can write architectural includes walls, comma, doors, comma, windows, and planning of spaces. This I'm giving in short: walls, comma, doors, comma, windows, and planning of spaces. So you'll find a number of options in architect. Just I'm giving the main points. Next you can write structural includes footings. Footing means the foundation of the building, comma, slab, comma, beams and columns. See, which bear the load of the building, including mechanical and electrical equipments, which will bear the load of the building, including electrical and mechanical equipments. So you see, that's the reason the structure again will update after completing this mechanical and electrical services based on the load of the equipment. For example, in a project, if you want to place a air cooled chiller, which is big in size, for example, I'll show you the image of chiller at the time of chapter 5. Assume at this level, just assume it's a big equipment if you're not aware of this, and with the load of say 1000 or 2000 or plus kgs, that means it is going to be in tons. So if you want to place this heavy equipment on the roof, the structure must design accordingly. So according to that, the structure people will take care for to bear the load. So, and one more point here, what do you think? This wall is a load on the building or will bear the load of the building?
No, not where the load is.
Wall itself is a load on the building, na? And you see this definition is for the common walls. But now in market we have a standard, or we have a special construction with the concrete walls, and the concrete wall is a structure member, not the architectural member. We have some special type of design in actual practice in present market. You'll find the concrete walls, and the concrete wall is not a architectural member, it's a structural member which is used to bear the load of the building. Okay, so you may find this type of construction also. It's a new as per my information. So remember, wall always not a load. It can bear the load also as per the type of construction in the modern construction now in market. Next, we have different types of drawing. First, we'll talk about the general drawings. See, first is a concept drawing or a tender drawing, which is prepared at the very initial stage of the project. Assume that you are the client and you are going to approach to whom? Say main consultant or a architect. So the main consultant or the architect will prepare very initial stage drawing, that is called concept drawing or a tender drawing. Concept drawing we are calling, as per technically it's a concept drawing. Tender drawing we are calling because this drawing is going to be submitted from the main consultant to the main contractor, or to the main contractor, or it can be for a small project to the design consultant. So for them it's a tender drawing because that is going to be a tender for them, na? So technically it's a concept drawing, but for process point of view, we can call it a tender drawing. So it's a very initial stage. You'll not find the detail in that. You'll find just basic information. Next, based on that concept drawing, the design consultant, you see, the design consultant, or it may submit to the main contractor. Again, the main contractor will provide this concept drawing, nothing but tender drawing, to the design consultant, who will prepare what? Design drawings. So design drawing, nothing but you'll find more details in that compared with the concept drawing. Concept drawing just an initial stage, very initial stage. But design drawing, in that you'll find the details, but not the complete details which is required to complete the work on site. So you may find say 70% information in the design drawing. Again, in the design drawing, you'll find the base drawing as well as the detail drawing. Base drawing means you'll find the single line drawings. Detail drawing with the double line drawing, almost the information, but not 100%. Not the complete. For a small project, you can consider the base drawing or detail drawing as same. But for big project, we require more detailing. So you need to go for a separate drawings. One is a base drawing and detail drawing, etc. Okay. Again, by the consultant. Next, based on that, the contracting company generally will prepare this shop drawing. Again, here contracting means I'm not talking about the main contracting. I'm talking about the subcontracting company. At this level, if you're a beginner, you may get the confusion between all these terms, but don't worry. Let me complete this. Again, we'll discuss with more detail about this process. At this level, I'm not just going in detail to avoid confusion. Just try to understand the terms and terminology. So shop drawing will prepare by whom? Generally in actual practice, by? Yes, online?
Contractor.
Yes, contractor. Because contractor is responsible for the installation. And again, you see, I'm not talking about the main contractor who is taking the overall responsibility for design and the build. Here I'm talking about a subcontractor, who is taking care for the HVAC site. Okay, again, you will find the separate subcontractor for the different services. Again, within the services also, you may find the further subcontractors, like a separate contractor for ducting side, separate for piping side, welders, etc. So the for big project, the process is very lengthy. But for a small project, one contractor will manage all these things. So remember, the shop drawing is a detailed drawing or it's an updated drawing of a design drawing, which is required for what? For execution, for installation on site, or we can call, say, the installation drawing. Shop drawing, technically we used to call shop drawing. You can call the installation drawing, which is required for installation point of view, and that you'll find the details for the hangers, the almost all the details which is required for installation. Again, in the design drawing, you see detail DLD, you'll find say 70 to 80%. But this is not completely. And for big project, the work is going to start on site with the detail drawing, with the design detail drawing only, because preparing shop drawing will take time. So almost say 60 to 70% is going to be the work is going to complete for big project with the design drawing. Parallelly, the shop drawing contracting company will prepare, and the final stage they are using the shop drawing. I'm talking about for big project. For small project, directly with the detailed design drawing, they can execute the job. Okay. Next, at the end, you'll find the as-built drawing. So what is as-built drawing? You see, in short, I can say the updated shop drawing is a as-built drawing based on the actual
Work done.
actual work
Actual
done
work
or
done.
actual installation or actual execution. Because see, in actual practice, because of the services, because of some other reasons, you may find some changes. The 100% the work is not going to happen as per the shop drawing. Definitely you'll find some changes, at least 5 to 10% changes, because we are talking about the services and we are not installing only one HV service in the building. Na? We have the other service. Again, in HVC also we have a different systems like piping, ducting, etc. So enough clearance is required. So you may find some changes because of coordination issues, because of some change in the design, change in the requirement, or sometime because of authority conditions, etc. So that's the reason the work is going to happen on site based on the shop drawing. But after completing the work, if any changes when compared with the shop drawing, that is going to update in the shop drawing. So the updated shop drawing as per the actual completion of work, that drawing is called as built drawing. As built, the name will give you the idea. As built, how you built, based on that we'll update the shop drawing. And why the need of the shop drawing? Because the work is already done. Why the need of this as built drawing?
Maintenance purpose.
Exactly.
No.
Yes. For, you see, for the billing, final bill, and for maintenance. Even for final bill also, the actual length of the pipe, the metal used, etc., that is going to extract with the actual conditions. No? So to prepare the final bill as well as next. Next, we have architectural drawing and different services drawing. And as an engineer, you should have the knowledge of this, because without knowing or without extracting the information from the architectural drawing, we cannot think to start to deal with any service. And in detail, we'll learn how to read this architectural drawing in building survey. At this level, just I'm giving the list of this drawings. So in architectural side also, you'll find the detailed drawing for the toilet, kitchen, staircase, wall section, doors and windows. So this two drawing is important for us as a HVC engineer, because this wall section will help you to get or to extract the metal use in wall construction. Apart from this, you'll find we require this metal used for the slab or for other structure member, and and even these doors and windows metal also required. And why this metal is required? If you can mechanical engineers can relate this to find the U value, overall coefficient of heat transfer, because the actual heat gain is depend on the U value. And if you don't know about the U value, don't worry. In load calculation, we'll talk about this finding U value based on the R value. It means resistance, thermal resistance of the metal. So this drawing is important. Next, furniture layout. Why the need of furniture layout for a HVC engineer to sell on OLX?
So I
Mm.
depend on U value, sir. Wouldn't
You see, no. You see, the furniture will not generate the heat. Furniture layout is required to extract the number of people, and the people generate the heat. Okay. Remember this point at the time of load calculation. I'll give you the note also. Don't worry. At this level, just remember this layout also required. Next, false ceiling layout, not only for mechanical, for HVAC, we required for other services, because all this
false ceiling layout means
the false ceiling, this false ceiling layout, in that you'll find you may find a step false ceiling, you may find the plain false ceiling, you may find the great false ceiling. So accordingly, we can place the 8 terminals. Na? False ceiling.
Yes.
Ceiling slab, I'm not talking about the ceiling, I'm talking about false ceiling. Okay, I believe everyone know what is false ceiling, because nowadays it's common, na? Even in small flats also you'll find the false ceiling. But don't worry, if anyone don't know, we will discuss the different types of false ceiling at the time of dealing with the design. Next, tiles layout for the flooring. This is not required. Names and legend. Okay, forget about this. But these are the types of drawing for architecture side. Apart from this, you may find some more also, but I have listed a few. In that, you see this wall section, this furniture. Apart from this, you'll find the different plan like floor plan, section, elevation, etc., which is also required. And we'll learn how to read this in detail, because extracting the information, you should know how to read this architecture layout. So in building survey, point one only, we'll discuss in detail. Next, structural drawings. Again, notes and legend, foundation plan, beams and column. And again, beams and column is required for a coordination point of view, because you see ducts, remember duct, we cannot run the duct through beams and column.
Yes, sir.
We can run the duct through the slab. Again, for that also, we need to coordinate at the initial stage, at the design stage with the structure engineer. Later, we cannot do the big openings in the slab also, because that will affect to the what load of the building, because structure means load. Now we cannot play with that with the structure members. Next, detail drawing, footings, beams, column, waterproofing, section drawing, etc. Just have given the list for information, but beams and column, and this is required for coordination to run the ducts, pipe, etc. Next, electrical drawings. Again, that notes and legends, site layout. This lighting layout is required at the time of placing the A terminals to get the idea or to understand the location of light fixtures, because where if the light fixture, if the area, some area occupied by the light fixture in the false ceiling means we cannot use that, no? So this lighting layout is required. Next, power layout for appliances, then power layout for HVAC point of view, because we are providing the equipment information to the electric people so that they can calculate the HVAC, or in short, I can say mechanical equipment loads, HVAC, plumbing, and firefighting. Next, fire alarm, security layouts, etc. So just list given, you can go through once. Next, if you talk about mechanical, under this, you'll find the this firefighting, different systems layout like sprinkler system, hose reel, hydrants, etc. Next, HVAC. This is important because in this training program, we are talking about the HVAC drawing now. Anyhow, you'll get the chance to deal with this layout in detail, even in drafting video course also. You see notes and legends. You'll find the abbreviation, notes, legends, etc. in this drawing. Next, side development plan, so that if it is a district cooling, the pipe is going to enter from outside to inside. So for that, side development plan is required. And what is side development plan? I'll show you at the time of reading architectural layout. Next, equipment layout, separate layout for the equipment. In that, you'll find the equipment like AHU, FCU, or exhaust equipments, etc. Hot chillers. You'll find the separate layout, and you'll find the separate layout for equipment schedule also. In that, you'll find the technical what I can say, this high class or high technical information in that about the equipment selection. So you'll find equipment schedule layout also. In that you'll find the text. It's not a drawing, but that again you'll find it in the layout form or in the drawing form, but it's not actually a drawing. You'll find the this text information. Next, A terminal layout. At the time again means A for A terminals. Then ducting layout. Then we require the piping layout, insulation separate, because you'll find a separate subcontractor for insulation. Next, refrigerant piping layout in case of DX systems, and in case of this, especially for this VR system also. Next, chill water piping. This also important for chillers. Find the separate drawings for the chill water. In that, you'll find the complete piping for the chill water. Again, the installation detail drawing for installing the AHU, installing the FAHU, installing the chiller, and other equipments, and the duct installation, pipe installation detail drawing, which is required on site at the time of execution. We'll learn how to read all this. Schematic drawing, in that you'll find the connection between this AHU chiller or this ducting, etc. Okay, so we'll discuss all this. This is just a list to get the idea. Similarly, you'll find the plumbing drawings. You can find the list. Plumbing is divided into water side and drainage side. So you'll find the hot water, cold water, isometric layout. This is important because in plumbing, isometric, even in HVAC and firefighting also, as per the requirement, sometimes we require isometric drawing, but especially for plumbing, isometric drawings are required. Next, drainage system layout, etc. Okay, so this is the list, and just go through once. As an engineer, you should have the idea of, apart from idea about the other services apart from this HVAC if you're dealing with the HVAC service. Next, we'll talk about installing the HVAC system. We discussed the design process now. Next, we have a installation process. So installation means, who is taking for installation HVAC or other services. It can be equipment, it can be chiller, it can be pipe. So the contractor will take care of this now, the contracting company. Again, don't get confused. I'm not talking about the main contracting company. I'm talking about the subcontractors. Okay.
Yeah,
Main
depend
Hmm.
on client to who will provide it.
Yes.
Yeah,
Depend as per the scope of work, depend as per the type of project, size of project, etc.
yes,
Okay.
sir.
At this level, assume that this contracting company is a subcontracting company who is taking care for the HVAC side only. Okay. If you talk about the main contractor will take care for all the services. Again, that main contractor will provide the job to the subcontractor. Again, the subcontractor, for example, consider HVAC subcontractor.
Yes, sir.
Again, the
Subcontractors.
HVAC subcontractor will provide the job to further subcontractor. Separate the contractor for duct side, separate for pipe, separate for
Yes, sir.
insulation, separate for welders, etc. So for big project, it's a big for big projects. It's a chain. But just at this level, installing the system, assume that I'm talking about HVAC subcontractor. So again, you see, now assume that the architect will have, or the main this consultant have all the drawings. All which drawing? The design drawing. Or you can consider the contractor. In case of big project, the main consultant will provide the job to the main contractor, and the main contractor will provide the job to the design consultant. Now assume that the design consultant completes the design, and the design drawing from the design consultant is submitting back to whom? Some main contractor. Now the main contractor will provide this drawing to whom? Subcontractor. So assume that this architect at this level is main contractor and providing the information and drawings to the general contracting company, and the general contracting company will provide the drawings to the subcontractor. So again, in subcontractor you'll find the structural, plumbing, electrical, HVAC, firing, etc. But at this level we bother about the HVAC, no? So we'll discuss about the
Sir,
HVAC.
just 1 minute, sir.
Yes,
So
please.
you are saying that architect is main consultant, right? But here
Yes,
again,
you can
but he,
consider the architect as a main consultant. But again, in main consultant, you'll find the architect and mechanical and electrical team of engineers. For
but
small project, you can assume this architect is a main consultant.
here you are saying that architect is the main contractor.
No, the main consultant or the owner consultant, and provide the job to the main contractor in case if it is a big project, or else directly he can provide the work to the subcontractors. So depend as per the case. So just focus on the concept. In actual practice, as per the location, as per the type of project, these options may vary. So the point is the contracting company will take care for say installation. So here I'm bothered about this HVAC. So what are the steps involved in installing the HVAC system that you'll find here? You see the mechanical or the HVAC contracting company take the HVAC consultant design drawing, also known as engineering or the contract drawing. You can call this a tender drawing. The tender drawing from this consultant to the contractor, we can call that as a tender drawing. Next, you'll find the term IFC also. IFC is to issue for construction, or else we can call the detailed design drawing is IFC, or the what we can call the shop drawing. You can consider IFC issue for construction. So as per the case. So in this case, you see the mechanical or the HVAC contracting company takes the HVAC consultant design drawing, also known as engineering or contract drawing, or say tender drawing, and then prepare what? Shop drawing, what we discussed at the types of in the types of drawing. Then shop drawings are the detail drawing, larger scale, minimum A2 or A1 sheet. I think as engineer, you know this paper sizes. The normal paper size is A4, na? So generally, if we'll not use A4 on site, we know A2 or A1 or A0, or you'll find larger than that. And most commonly, we are using 1:100 scale. Can be 1:50, 1:150, 1:200, depend. But commonly 1:100. And if you're not aware of this scale, don't worry. We'll discuss at the time of dealing with the design. 1:100 means, just I'll give you the idea. In actual practice, it is 100 times, but in drawing, you can find only one time. For example, in drawing 1 mm equal to in actual practice 100 mm, or in drawing 1 feet equal to in actual practice is 100 feet. Okay, because we don't have that much of big sizes of sheet, na? So that reduction is required. So 1:100 means 100 times you're going to reduce. So most commonly scale we are using in actual practice, and on-site scale drawings are required, or else it can be a big issue on site Because if you talk about the duct length, pipe length, etc., they will cut according to the scale in the drawing. They will measure in the scale and they'll multiply with 100. So 100 is a multiplication factor if you're using 1:100 scale. So this is very, very important. So shop drawings are detailed drawing, larger scale, A2 or A1 or A0C with the 1:100 of the HVAC system, which will be necessary for the workers to work on the site. Next, you see the HVAC contracting company has the people who includes sheet metal contractor. Here I'm talking about subcontractors. You see the contractor, the HVAC contractor will hire the subcontractor, or else they may have the team of this workers. So depend as per the case. Some contracting company have their workers on salary basis. So if there is a work or not, they will pay the salary, or else some contracting company, whenever they get the job, they will contact to the subcontractors. So as per the job, they will pay, and after that, then they will not pay. They are not the permanent workers for their contracting company. So as per the case, so if it is a big contracting company, you may find their own team of workers for separate sheet metal, means for ducting, separate pipe fitters for piping, etc. Or else it can be a separate subcontractor, depend as per the requirement or as per the type of company. At this level, I'm assuming that the main contracting company will divide the job to the subcontract company. That subcontractor company, one is a sheet metal contractor who is taking care for this ducting side. Here is an example for the duct. They will fabricate the duct, means making of duct, and they will do the installation for the duct. Next, you see pipe fitters, they will take care for this welding and installation of pipe for this refrigerant side or for chill water side, etc. Then separate insulation contractor who will take care for duct insulation as well as for pipe insulation. At this level, if you don't know insulation, just remember insulation is used to reduce the energy losses. We have a separate topic for insulation and installation in the installation video course. Next, the HVAC contract company also purchased all necessary HVAC machine and the metal. To do this, the engineer first carried out a metal takeoff, nothing but estimation. And in this training program, we are offering this estimation video calls also with the complete tower project. This is also important, and it's a lengthy task. It means, you see, they list all the machine and metal as shown on the drawing with the specification. This is very, very important. You must follow the specification as per the requirement of the project. Okay, and the specification, who is going to decide the specification?
Design and
The consultants. They are taking the responsibility, na? And the specification by the consultant is going to follow by the contracting company. Okay, the contracting company follow the specification, and the specs from this consultant they will provide in the PDF, or we can say PTS, project technical specifications in short. Next, this can be a very involving task. So it's a lengthy task, and you must read the specification, you must read the drawing, you must extract the material. So it's a very lengthy task. That is nothing but metal takeoff. Now assume that the installation is done. The ducting installation is done, piping installation. Just assume that after completing all this, purchasing all this metal, after this metal takeoff and all. So after installation, then what? We require the tab work. Nothing but testing, adjusting, and balancing. Again, the tab work also take care by whom? The contracting company. Or else for very big project, the contracting company may hire a separate company, or they will provide this job to a separate company who's taking care for this, especially for this tab work. For the tab work, we have this separate society. Forgot that name. BE, Bureau of, I forgot that term. We have a separate society for that tab work. Anyone remember that one? Some BEE, or I forgot that one. Okay, I'll get back to you. This you'll find a separate society for this tab work. They are dealing with the research and development for this testing, adjusting, and balancing. I forgot that term. Okay, I've given the instruction. I'll get next. So now you see, after completing the tab work and the quality check, this Q and QC, this is also required. Again, this Q and QC will take care by the contracting company, or else the main consultant or the client may appoint the third party for this Q and QC for additional verification in big project, or else this will take care by the contracting company.
It's IEEE, I think. It's IEEE, the societies.
IEEE. No. One more specifically for this tab work only. I'll get. Now you see, after completion of tab work and quality check, as-built drawing. You know what is as-built drawing? What we discussed, no? Can be prepared as per site modification for final bill and for service and maintenance purpose. Okay. So this is a process for the design and installation in actual practice for HVAC. And if you talk about the other services, the process is almost same. So this was about chapter 2. Sorry, my mistake. We have two more topics to discuss. Role of a HVAC design engineer and the role of a HVAC execution engineer. I've given in the list. You can go through once. Okay, I'll not explain in the class because this responsibility we'll discuss after a few classes, after getting at least chapter 5. At this level, you will not get anything, this terms and terminology. Because you see, till now, what I explained also in that also some terms and terminology is new for beginners. I'll hold this topic. We'll discuss after completing this chapter 5. Okay, with the chapter 5, at least you'll get the idea about the systems, etc. But I request to go through once all these steps. If you're a beginner, you must read at least 2 to 3 times and try to understand the process. Who is consultant, who is contractor, what are the different types of drawing, and who is responsible for what, so that when you in actual practice, when you involve in the contracting side, you'll get the idea how my role is to for installation side. If you involve in the consultant side, you'll get the idea my role is for in the design side. Again, in design side, you'll find the supervision site supervision team, or even in contracting also you'll find the design review team. So for reviewing the design, or to prepare the shop drawing, or to verify the design as per the requirement. Okay, so if you know this, then this will help you for understanding the process, so that and especially the design steps what we discuss, because all these design steps I'm going to expand in the next classes. This is very important. Even for entry point of view also, these steps are very important. So I'm going to expand all this in detail in the next classes. So any questions online?
Sir, one question.
Yes, please.
It's related to the installation. Okay.
Mm-hmm.
So when I'm working on Revit, at that time I need to define the levels of services as per the coordination point of view. Yes, sir. So when I'm working on Revit, at the time I need to select the levels of services, like above the false ceilings, like plumbing levels, ducting level, cable truss. Okay, so what's the reasons behind that? Cable truss will be above the footing and all these things, and firefighting levels. So can you explain those things?
Yes. So first of all, your question, what you asked at the beginning, Revit.
That is when I'm working on the Revit.
Okay. So you're working on the Revit. So forget about the Revit. So your question is why this cable tray is above this duct, right?
Not only cable trays, that means how the levels are adjusted, the coordination point of view, so that it cannot be clashes with other services.
This is very important point. And in building survey chapter 6, we have point number 8 related to this. In detail we'll discuss. I'll give you quick idea. Means you're talking about related to this image, right?
Yeah,
able to see this
cable trays and ducting.
So your question is how to decide this position or this levels?
Not positions, related to levels.
So you see, these levels are very important, because you see, if issue in one level will affect all the services.
And it's a very difficult job to accommodate. For example, 1 feet false ceilings, 2 ceilings gap, and something like that.
So you see, first of all, in order to decide this, experience is required, and that's the reason in actual practice, this decision is going to take care by the architect or a senior mechanical or electrical engineers. Because without experience, you cannot decide this. And you see, above the false ceiling, you'll find the limited clearance, and in that clearance, we need to set all this.
Yes.
So you see, there is no question of reducing this cable tray height, because this is a standard. We cannot work on this. And even this pipes, even this firefighting pipes or distill water pipe or for drainage pipe, we cannot we don't have much scope in that to reduce that, because this is based on the design. So now we have a option for this duct. So remember, this height of the duct, we are going to decide as per the available clearance, considering the clearance required for other service. And this is very important. And as a HVAC design engineer, this point, as I said, we'll discuss in chapter 6, point number 8. And this is related to, again, duct designing. And if you talk about duct designing, most commonly we are using rectangle duct. Can be oval duct, it can be round duct. We have this advantage and disadvantage, but most commonly rectangle duct. And rectangle means including square. We are not calling separate square category. So remember the height of the duct. If I use the term height, means it is related to rectangle including square. There is no question of height for the round and oval. For that we have a dia. So forget about round and oval. For rectangle or including square, the height of the duct will decide as per the clearance available, considering the other services required clearance. This is one reference. But again, this is not that much easy, or you cannot you can once can take the quick decision. They need some experience. Based on that, you can able to judge, because you see, again, in height of the duct also we have some limitation. Suppose
Okay.
considering all the services, and for the height of the duct, if it gets only 6 inch, we cannot design the duct for 6 inch height, except this exhaust system for small toilet area. And that
Yeah.
is different. But for supply duct for air conditioning, 6 inch height means you cannot design this, because if you reduce the height, the width will increase, and we have a limitation aspect magnet to maintain this aspect ratio.
Yes, yes.
Okay, but at this level, we'll not go in that depth, because the beginners will get confusion, or
Yes.
they may get panic.
I can relate.
Okay, so hope you got the answer to your question.
That means why the firefighting lines are below, and cable trays, and then firefighting lines. I can see that it's.
Now your question is the position, related to position, right?
Yeah, 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 yeah.
Okay, so you see, first of all, this cable tray is above the duct, so that if any condensation happen on the duct, will not lead to the short circuit. This is for safety point of view. Okay, this is a standard practice, but in actual practice, you may find the cable tray running below the duct. That because of the coordination issue, because of such side condition. But if you talk about standard practice, the cable tray should be above the false ceiling, because you will not find much maintenance in this cables, na? And this firefighting pipe below the duct, because for maintenance point of view. But again, in actual practice, you may find the firefighting pipe above the duct also, but it is recommended to run the firefighting pipe below the duct, so that will be easy for maintenance, because the firefighting system used only in case of fire event. Till that time, the proper maintenance is required. They need to check that the condition of the pipe or any leakages, etc.
Sir, another thing is that I can say that in the Indian buildings,
Mhm.
they'll provide the sleeves in the beams to
Mhm.
pass the firefighting lines. So the structural engineer will allow this to penetrate these beams. It's a good
Yes, yes,
practice, or it will
yes.
weaken the buildings.
Okay, for that also, you're talking about this, right?
It's a it's a vertical slab. It's a vertical sleeves in the but I can see the horizontal sleeves like on the on the
Yeah, you see,
beams.
you'll find the sleeves in the beam, column, or even in slab. So it is allowed, no issue. But at the design stage only. Later, the means after completing the structure, they will not allow to do the opening or they are not allowed to disturb the structure map. But initially, at the time of design stage, if you coordinate, definitely they will design the structure accordingly, considering this opening for this pipes, because they will design the structure accordingly, because you see, this much of metal is lost now in the structure in this slab, so they
Mhm.
will design the slab accordingly. Similarly, for beams and column, if you are looking, if you ask for the pipe sleeves, so they will design the structure according. So at the design stage, yes, it is totally accepted, it's possible. But later, opening is not allowed, except some special cases, that too for small.
I can see that all the sprinkler lines
Mhm.
passing through the beams only. That
And you
means
see,
in the
even the chill water pipe also can pass through the beam. But
yeah.
initially, the pipe sleeves are required at the time of the construction only. And the construction means that should be as per the design. Okay, I'll show you this at the time of piping. I'll show you some images. In that, you'll find the pipe sleeves for the chill water, pipe sleeve for this firefighting, even for plumbing. That is accepted, no issue.
And
But
another question,
mhm,
you said that drawings we are maintaining 1:100 drawings. Okay,
1:100
so
scale.
yes, it 1
Mhm,
to 100 scales. So
mhm,
dimensions will be mentioned in the drawing, right? In the
mhm,
shop drawing. So you're saying that multiplications by 100 when we are
mhm.
going to cut the duct. At the side, they're going to measure the drawings, or they will check the dimensions.
You see, for width and height, it is written in the drawing for the duct. But what about length? Length is not mentioned, na? So they will measure the length
In the
on.
shop drawing, contractor is going to mention the length. I think they're going to mention
Yeah, you see,
length
some
also.
in some projects you'll find the length also, but not commonly. Even if it is mentioned, a fabricator. And nowadays in actual practice, you see, means last 5 years back, or say 10 years back, the fabrication on site, but now it is a factory fabricated. Okay,
Yeah.
so they must verify. They will verify the drawing with the scale factor, and they must do this, or else what will happen if they not verify means. Without that, if they start production for this ducting means, that there will be no use, because either you may get length more than the required or less than the required.
Okay, that was
So the scale,
manually they're going to check the length with the scale on the paper.
yes, with the scale they will measure. For example, it is written say 100 in the drawing, they will measure. So they must get some 1 but 1 is small, say 1 centimeter, for example. So if 1 centimeter, they will consider hundreds and they will verify. And this is important. And experienced contractor will check the scale when he got the drawing, not only for HVAC, even for other services. Okay, then, thank you.